All right, let's get into it. Today, we're going to break down one of the most important essays in all of modern AI, Rich Sutton's The Bitter Lesson. It's this really powerful look back at the last 70 years of AI research, and it reveals a surprising and, for a lot of people, a kind of difficult truth about how we actually build intelligent machines.
So everything really boils down to this one question. This is the debate that has shaped the entire field of AI from the very beginning. Do we try to build machines in our own image, painstakingly coding in all the clever, complex ways that we think? Or do we go down a totally different path, one that relies less on our human genius and a whole lot more on just raw computational horsepower? At its heart, this is a clash between two completely different ways of thinking. You've got these two camps. In one corner, you have this very human desire to build our own knowledge, our intuition, our smarts right into the machine. And in the other corner, you have an approach that's all about using general methods that can just soak up massive amounts of computational power. And this really lays out the two sides perfectly. Look at the human knowledge approach on the left. It just feels right, doesn't it? It's super satisfying for a researcher to pour their expertise into a machine. And yeah, it works pretty well in the short term. But then, look at the right. The leveraging computation approach, well, it's all about playing the long game. It uses big, general ideas that just get better and better as computers get faster. And as we're about to see, that's the one that always wins. And that brings us to the lesson itself, the big reveal. After decades of trying things out, the results are in. The most powerful way to build AI isn't to carefully program it with everything we know. Nope. It's to harness the insane, ever-growing power of computation and just let the machine figure it out for itself. Now, this isn't just some abstract theory. This is a pattern that has shown up again and again and again in pretty much every major area of AI research. So let's actually look at the proof. Just look at this timeline. You go back to the 70s with speech recognition. People tried to build systems based on the rules of human language, and they got beaten by statistical models that just crunched tons of audio data. Fast forward to 1997. Deep Blue's brute force search beats the greatest chess player alive. Then in 2016, AlphaGo does the exact same thing in Go, a game people thought was way too creative for computers. You see the pattern here? It's just undeniable. Let's dig into chess for a second. The first impulse, the obvious idea, was to make the computer think like a grandmaster. Teach it about elegant strategies, positional play, all the beautiful nuances of the game. It just seemed like the only way you could ever achieve real mastery. But the approach that actually won, it was Deep Blue, just searching through millions and millions of moves a second. A lot of researchers saw that as just brute force. It didn't feel smart or elegant. And this, right here, is the bitter part of the lesson. Their favorite human-centric way of doing things had lost, and frankly, it was a tough pill for them to swallow. And this wasn't a one-time thing. It's the same story everywhere you look. In Go, trying to bake in human strategies turned out to be useless. For speech recognition, systems built on phonemes, the building blocks of speech, they got absolutely crushed by statistical methods. And in computer vision, the early idea was to teach a computer to see edges and shapes. That turned out to be a total dead end, compared to modern networks that just learn by looking at millions of pictures. Okay, so you have to ask yourself, why does this pattern keep repeating? What's the secret sauce here? What is the underlying engine that's driving this? And the answer, in 2 words, is Moore's Law. See, researchers build systems for the computers they have on their desk today, but the ground is constantly shifting underneath them because computers are getting exponentially more powerful all the time. So any method that's built to take advantage of that growth is just bound to win against methods that rely on the much slower process of a human researcher having a clever idea. And it turns out there are 2 big methods that are perfectly designed to ride this massive wave of computation. The first one is search. That's just exploring a mind-boggling number of possibilities, like a chess computer looking at all the future moves. The second one is learning. That's finding patterns in massive amounts of data. And that, by the way, is the engine behind all the huge AI models you hear about today. So this all creates a cycle that you can practically set your watch to. Step 1, researchers build in their own brilliant ideas. Step 2, it works for a little while. Step 3, that approach hits a hard ceiling and progress stalls. And then step 4, a huge breakthrough comes from a totally different angle, one that just throws more search and more learning at the problem with bigger computers. This exact story is playing out right now, today, on an incredible scale. So what do we do with this?
What's the big takeaway from this bitter lesson? What does it tell us about how we should even be thinking about building AI going forward?
Well, the reason it stings, the reason it's bitter, is because it's humbling. It's an ego check. It suggests that the beautiful, intricate, complex machine that is the human mind might not actually be the best blueprint. It is really hard to accept that a simple algorithm, if you just give it enough data and enough computer power, can blow past decades of carefully curated human expertise. And that means the ultimate goal has to change. We need to stop trying to build systems that just contain everything we already know. Instead, we should be building systems that have the power to discover knowledge all on their own. It's like we shouldn't be giving them the answers to the test. We should be giving them the tools to figure out the answers for themselves.
And that leaves us with this final kind of mind-bending question. If we really lean into this lesson, if we build systems based on search and learning at a scale we can barely even imagine, then we're not just copying human intelligence anymore. We're creating a totally new kind of discovery engine. So what new ideas, what new science, what completely new forms of art are these systems going to find out there in the vast universe of possibilities that our own minds, that our minds could never have the time or power to explore? It's an incredible thought. Thanks so much for tuning in.